Hello everyone, I hope you're doing fine. I also hope you were able to look at the answers to worksheet 8.1 that I posted yesterday for you. If you have any questions, please just let me know. Today I'm going to start section 8.2. This is a pretty large section, so I'm going to break it into two video lessons. So for today I'm going to give the start of section 8.2 and part of the worksheet to do for today and tomorrow, and then on Thursday I'll pick back up with the second method to do a z-test for me. So in sections 8.2 and 8.3, they cover the two statistical tests. Within each section, there's going to be a traditional method and a p-value method. So today I'm going to talk about the traditional method. On Thursday, we'll go over examples of the p-value method. It's just two different ways to calculate values to compare. So remember, we're going to use a z-test or the standard normal distribution when our population deviation, standard deviation is known, and we use a t-distribution or the t-test when our population standard deviation is unknown. So we're going to talk about, again, traditional and a p-value method when we get to section 8.3, which will be next week. I also hope you guys were able, if you don't have your own calculator, you found that website very useful, and you can use it as we go through some of our examples today. Alright, so the general formula we're going to use to find the test value. If you remember, I gave you 5 steps, we wrote out 5 steps for hypothesis testing last week, and one of those steps was to calculate the test value. So this is the general formula we're going to be looking at. It's the observed value minus the expected value over the standard error. Or translated into symbols, we have x bar minus mu divided by the standard error was the population standard deviation over the square root of n. This came from chapter 6 when we talked about 6.3, I think it was, the central limit theorem. So just know that we're going to be using this formula. So a couple ways we could refer to x bar, which is the observed value. It's also the sample mean, which we're very familiar with. Or it could just be any statistic calculated from the sample. Remember, the word statistic goes along with being a calculation from a sample. Mu is the expected value or the population mean. It's also a parameter. So parameter and statistic mean the same things, just some value calculated, but again, a sample versus a population. It's also the mu is also referred to as the hypothesized value, and we would expect to obtain it if our null hypothesis is true. So there's two outcomes of hypothesis testing situation, two cases here, depending on what we identify as our claim. And in our examples, it should be noted what our claim is, but sometimes it could come up where you may feel the claim is the null hypothesis or the alternative hypothesis. As long as you're able to support your reasoning, then we're good. But in most examples, it's going to be clearly stated what the claim is. So if our claim happens to be the null hypothesis, these are going over how to word steps 4 and 5 from our 5-step hypothesis testing. Step 4 is the decision. So we have two decisions we can make. We could either reject the null hypothesis or we do not reject the null hypothesis. The summary is going to be stated as I have written here, just as we always had to write out our confidence interval summary. So again, if our claim is a null hypothesis, we reject the null hypothesis as our decision, then we want to write that there's enough evidence to reject the claim. So it's like we want to just kick the null hypothesis out of the way. So we reject the claim, and we're going to just use the same wording that's given to us in our problem on what that claim is. If we happen to not reject our null hypothesis, we're not kicking it away, we say there is not enough evidence to reject the claim that, and again, whatever it may be, however it may be worded. So notice we have the words reject in each summary. If our claim is the alternative hypothesis, again, step 4, decision remains the same, to reject the null hypothesis or do not reject. But now our summary for step 5, if we do reject the null hypothesis, then our claim is the other hypothesis. We say there's enough evidence to support. So when our claim is the alternative hypothesis, we use the word support and not reject. We can only reject the null hypothesis. So there's enough evidence to support the claim that, and then if we do not reject the null hypothesis, this kind of means we're going with it. So we can't support our claim. There's not enough evidence to support the claim that, again, whatever may be the case. So we're going to take a look at some examples, 3 examples here. So for this first one, mentioning the number of days on a dealer's lot, a researcher wishes to see if the mean number of days that a basic low price small automobile sits on a dealer's lot is 29. Sample of 30 dealers has a mean of 30.1 days for a basic low price small car here. Alpha should also be given to us, so alpha is 0.05. Now, even though it says a researcher wishes to see if the mean number of days is still going to be 29, notice over here it says test the claim that the mean time is greater than 29 days. So because it's specifically worded that way, our alternative hypothesis is going to be our claim. Notice it's also giving us that the standard deviation of the population is 3.8 days. So to go through the 5-step process here, step 1 is to write out each hypothesis. So remember, our null hypothesis is that mu equals the 29. The alternative hypothesis is that mu is going to be greater than 29. And this is our claim, because the problem mentioned it. We want to test this claim. So step 2 is to calculate our critical value. I'm going to abbreviate this as CV. If you sketch a picture of the normal distribution here, with alpha being 0.05 and with this being greater than, this is a right-tailed test. So over here, this is our alpha equals 0.05. This is also the rejection region, or the critical region. The 95%, if our test value falls over here, we do not reject. It's the non-critical region. So if it's over here, we do not reject the null hypothesis. But first, let's find this critical value. We need to figure out what this critical value is here. Remember, it's the wall that's separating the two regions. So what we're going to do here is, again, with alpha being 0.05, on the calculator, or if you guys go to the website that I gave you, we need to type in that 95% of the area is to the left. So when we do that, our critical value turns out to be 1.64. So you can go ahead and just double check that. So this value right here is 1.64. Step 3 is to find the z test value. I'm just going to call it the test value. And please label it like this. So this is our x bar, which is 30.1, minus mu, which is 29, divided by our population standard deviation, which is 3.8, and then we're going to divide that by the square root of our sample size, which is 30. So if you want, go ahead and pause the video to calculate this. But you should end up with a 1.59, and we could just round that to the same number of decimal places as our critical value is, which would just be 2. So this means 1.59 is going to be to the left or below the 1.64. So this falls in the non-critical region. So that means step 4, our decision, is that we do not reject the null hypothesis. Okay, now we're going to go back to the previous page. I'll just go back real quick. So our claim is the alternative hypothesis, and our decision was that we do not reject the null hypothesis. So that's the second case. We do not reject, so we're using this summary right here, that there is not enough evidence to support the claim. So then step 5, which is our summary. We would say there is not enough evidence to support the claim that the mean time on the lot is greater than 29 days. know the summary is a lot to write, but it is very important. So if you need to, you can revisit the steps here, but we are going to go through 2 more examples. And as I always say, if you have any questions, please email me. All right, our second example, if you wish to pause the video, you want to type all this in. I know it's a lot of numbers, but into a list and spreadsheet on your calculator. When I give you the raw data like this, we're after X bar, so you want to do the stat calculations. If you don't have your calculator, just go to a Google Sheet, and you could type in all these values, and then remember, in order to calculate an average, a sample mean, you want to go to equals, and then, or just in a new cell, and just go equals average, and then you could type the range of whatever cells it's showing up. So if it's like A1 to A37 or A36, depending on where you start, that's what you want to do. So I believe it should be equals average, and then you would type in like cell A1 to A36, if that works that way. If it doesn't, please let me know. All right, so go ahead and pause the video, and you can calculate that. All right, so hopefully you were able to come up with X bar equals 75. Notice I'm giving you that our population standard deviation is 19.2. Alpha is at 10%. All right, so looking at our step 1, our null hypothesis. If you notice at the very beginning, a researcher claims that the average cost of men's athletic shoes is going to be less than $80. So that means mu for our null hypothesis is going to be that it does equal $80. And here's mu is less than 80. This is also our claim. As I mentioned before, most of the claims will be the alternative hypothesis, which is also called the research hypothesis. All right, so step 2 is to find that critical value. We're going to make a sketch of the normal distribution. Since it's less than, this is a left-tailed test, so we're looking at 10% being over here. So alpha is 10%. Again, if our test value falls in this region, we reject. So if our test value does fall over here, we end up rejecting H naught. If it's over here, we do not reject our null hypothesis. All right, so go ahead and type in the 0.10 as the area to the left. Again, you can pause the video while you do that. We should expect a negative number since we're below the middle of the curve there. So we should be getting a negative 1.28 as our critical value. Step 3, our test value turns out to be 75, that's our sample mean, minus 80, divided by our population standard deviation is 19.2, and then the square root of, we have 36 data values here. Right, and this should come out to be, again, you can pause the video, negative 1.56. So negative 1.56, if we go over here, this is our critical value of negative 1.28. So negative 1.56 will end up in that shaded region. So then our decision is to reject the null hypothesis. All right, so again, our claim is the alternative hypothesis. We end up rejecting the null hypothesis. So our 5th step, our summary, is that there is enough evidence to support the claim. So we could get rid of that null hypothesis and go with our claim here. So there is enough evidence to support the claim. And as we just get started, I'm fine if we clearly state this up here. We don't have to keep writing it. So for a lot of these, you're going to see that I even just stop as after the word claim. But if we wanted to continue, claim is actually that the average cost of men's athletic shoes is less than $80. But a second example, again, both examples 1 and 2, everything we're doing in this lesson today is the traditional method where we find the critical value and the test value. So let's go ahead and try one more example, which is about the cost of rehabilitation. So this Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is $26,343. Standard deviation of the population is 3251. Alpha is 0.01. Can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from this $24,672? That last part tells us that that's going to be our claim. So good news is we don't have the raw data. Everything is found for us. So step 1 is that our null hypothesis is that mu is going to equal this 24,672. Alternative hypothesis is that mu is going to be something different than the 24,672. So this is our claim. Because it's not equal to, this is a two-tailed test, so if we draw our little sketch, we have this little area here, and I'm making it larger on purpose just so we can see it better. But since alpha is 0.01, this little bit over here, alpha over 2 is 0.005, also over here. Alright, so when you go to type this into your calculator, you're typing in the 0.005 to find our critical value. Go ahead and pause and calculate this. But you should be getting, when you just type in the 0.005, a negative 2.58, but just know it's plus or minus. So here we get a negative 2.58, over here we get a positive 2.58. Again, if our test value for step 3 ends up in the shaded region, then we reject the null hypothesis. So let's go ahead and do step 3. Alright, so our sample mean is going to be the 26,343 minus the 24,672 all over the 3251 here, divided by the square root of 35. Again, pause to calculate that. And we should be getting a 3.04. So 3.04 shows up over here. So our decision is to reject the null hypothesis. Now, once we start writing these for a while, you don't have to keep writing decision. You could just, you don't even have to number them, but please, I would still show them this way, that we could just say reject the null hypothesis and then write the summary after it. Again, you don't have to write the word summary. Alright, so our claim again is the alternative hypothesis. We reject the null hypothesis, so then we say there's enough evidence to support our claim. Again, just go back and read what the claim was again. So we want to see if the average cost of rehabilitation is different at a particular hospital. And again, different from the 24,672. All right, so please go back over these examples. The worksheet that I'm going to give you guys, I'll assign I'm going to assign it separately, so it's not in this video. I will post it as a separate PDF. I just want you doing problems 1 through 7. So look at this video for today, try the worksheet today and tomorrow, and then I will post answers, go over it on Thursday with the new lessons and new examples using the p-value. But I really want you guys to focus on these and understand the traditional method. As always, email me if you have any questions.